Capecci's Corner, we're going to look at solving exponential equations and inequalities. Okay, when we get started, we'll look at some property of equality. So basically what we want is we always want the base to be the same. Base is the same. When we have the base the same, then we can compare the exponents. So in this case, x would equal to 5. Okay, so let's get a little bit more involved in number 1. So again, I want my base to be the same. So I know that I can change 8 to a base of 2 because 2 to the third power is 8. So that takes care of the 8. I'm going to have to raise that to the third power. Now my bases are the same, so I have some equality going on here. I have x is equal to 3 times 3 gives me 9. So there's my final answer right there. Or I could have done x to the x is equal to 2 to the 9th power. I could have done that one first. Okay, now it's a great idea to always check. These are quick ones to check. So I can check this and say, well, 2 to the 9th is equal to 8 to the 3rd. And when you use your calculator, you can see that that works. All right, let's look to the next one. Okay, so my goal here is to get the same base again, and I want it to be to the 3rd power. So I can take 3 to the 2nd, right? I have a 3 over here. I know that gives me 9. And I'm going to raise that to the 2x minus 1, which is equal to 3 to the 6x power. Now, my bases are the same. So I'm going to get 2 times 2x minus 1 is equal to 6x. Now, this just becomes a basic algebra problem. And I want to get x by itself. So I have 2x is equal to negative 2. So x is equal to negative 1. And again, I could put that in and check it. So I have 9 to the 2 minus 1 gives me negative 2. Minus 1 gives me the negative 3rd power is equal to 3 times the negative 6th power. And again, when you check that using your calculator, you can see that that's correct. All right, moving on to number 3. Again, my goal here is going to be keep to the base of 4. So 6 to the 4th is 4 to the 3rd power. So I have 2n minus 1 is equal to 3. So 2n is equal to 4 and n is equal to 2. Now, I could have done another way. I can also work with my base of 2. So if that's the case, I could have done 2 raised to the 2nd power, right? That gives me 4. Also raised to 2n minus 1 is equal to 2 to the 6th power. So in this case, I would have gotten 4n minus 2 is equal to 6. 4n is equal to 8. So n is equal to 2. So again, I would have gotten the same answer. It doesn't matter which way you do it in that particular problem. And again, I can check to make sure I'm okay. All right, let's move on. Now we're going to look to have the same idea, but now we're going to work with some fractions, right? So we have some negative exponents. This gives me 9 to the x power is equal to, this is 9 to the negative 2 power, right? And if you need to break it down further, you can do that first if you can't see that. And again, I have x to the negative 2 power. So I'm sorry, x is equal to negative 2. Okay, now again, you can check that. If I want to check it, I have 9 to the negative 2 is equal to 1 over 81, which is true, so I know I'm all set. All right, let's look at number 5. Again, 625 is the same as 5 to the negative 4th. So I have 3 minus 2x is equal to negative 4. So I have negative 2x is equal to negative 7. Divide both sides by negative 2, and x is equal to 7 over 2, which even though is a fraction is okay. And again, you can substitute it back in to make sure it works. Now we're going to do the same sort of thing, but we're going to work on inequality. So instead of an equal sign, we're going to just change it to an inequality, so our answers will look a little different, but the idea is the same. We want to make sure that we have the base the same. So this is 2 to the 4th power, right? I can use the base of 2, and I look at 16 and 8. That's the way I want to go. And I have the 2x minus 3 is less than 2 to the 3rd. So again, I get 4 times 2x minus 3 is going to be less than 3. So I have 8x minus 12 is less than 3. So 8x is less than 15. So x is less than 15 over 8. So I'm going to write that, little brackets, x such that x is less than 15 over 8. And that's my final answer right there. All right, let's move on to the next one. 243, this is the same as 3 to the negative 5th power. So I have 2x minus 1 is greater than or equal to negative 5. So 2x is greater than or equal to negative 4. and x is greater than or equal to -2. So again, x such that x is greater than or equal to -2. Okay? Now again, let's look at number 8. We're going to deal to the fourth power again. We could use 2 if we wanted, but the fourth power is probably going to be the easiest. So I'm going to say that this is, change this. This is going to be the same. And this is 4 to the third power raised to the 2x minus 4. So I have 2x plus 6 is greater than 3 times 2x gives me 6x, and then I have minus 12. Okay, I'm going to bring my 2x to the other side. And I have 6 is greater than 4x minus 12. Add the 12. So I have 18 is greater than 4x. Divide both sides by 4. So this gives me 9 over 2 is greater than x, or x is less than 9 over 2, which is 4.5. So we can use it that way if we like. Okay, so I'm going to say, let's see, I have x such that x is less than 4.5. All right, moving on. Now we have a word problem. Okay, it's all about compound interest. We do a lot in math with compound interest. It's a great business problem to work on. Compound interest is interest paid on the principal of an investment and any previous interest earned. So interest on your interest. This is what banks do. You put $100 in and you get interest on that $100. You're going to get interest not only on your $100, but on any interest you've earned since then. Okay, so this is the formula. And this is what everything stands for. A is the amount after interest is calculated, your total amount, like your total amount in the bank. P is your principal. That's the amount that you start with or the amount that you put in the bank. R is your annual interest rate. Okay. Now, N down here, we're using N a lot. N is the number of compounding periods each year. So if I say something is done annually, we know that means once a year. Semi-annually is twice a year. Weekly, there's 52 weeks in a year, so we'll say 52. Monthly is 12, and bi-monthly means twice a month, so that's 24. Okay, so let's look at our given problem. An investment account pays 4.2% annual interest, so we need to know annual as well. Account pen and monthly. If $2,500 invested in the account, what will the balance be after 25 years? Okay, so we're going to try to find out how much is going to be there at the end. So our P, or our initial investment, our principal is $2,500. I have 1 plus the rate is 0.042. That's how we write that as a decimal. Over N, remember N right here is the number of times it's compounded in the period, and they tell us annually. So we're going to talk about, it says compound monthly, so that's going to be important there. So we're going to do 12 there. Now, I'm going to raise that to the N times T. So N, again, we said it was compounded monthly, so that's 12. And then T, and then we have for 15 years, right? That's the amount of time that we're talking about. So the easiest thing to do all this in your calculator. If you want to do this part first and then raise that to your power, there's a lot of different ways you can do it with your calculator. You can do it all kind of in one if you have a nice calculator that you can kind of just go from left to right. So at the end, once you put that in your calculator, the balance after 15 years would be $4,688, and we'll round off. I'll find our final answer there till 87 cents. Okay. Thanks so much for stopping by today. You have a great day.